Hi, teacher. This is my project. Um, we will solve this exercise. It's a people who get into Walmart follow a Poisson process of intensity 4. That's it. 4 person get into per hour. Get into Walmart. It's open at 8 o'clock. This problem has two exercise, but first I will give you a little introduction about Poisson process. Uh, a Poisson process is a stochastic process. And what is a stochastic process? Well, it's a random variable that is indexed to another variable. In our example, the indexed variable will be the time. That's the reason I write at t here. And the n of t, that is the random variable, will count the number of customers that get into Walmart to a time t. In another word, the Poisson process is a contained process which will count the occurrence of event in the time. It means that this variable n of t will evolve over time. Uh, we need two conditions to count events with Poisson process, and the first is that the Poisson process the process must be homogeneous on time. And what is this? Uh, it say that if we well this n t plus h uh, will count the customers that get into between the our team to the our t plus h. Uh, if we want to count how many customers get into Walmart between 9 o'clock and 10 o'clock, uh, t is equal 9 and h is equal 1. And this property say us that uh, uh, that the person who arrives no depends of team, no depends of when we no depend the hour that we want to start to count. Depend the length of the interval. If we take an interval of 9 o'clock to 10 o'clock and another interval of 13 o'clock to 14 o'clock, the person who arrives in this uh, in these two intervals will be the same because the interval is the 1 hour, the both. And if we take an interval of 2 hours, more person will get into in 2 hours than in 1 hours, but the same person get into in 1 hours and 1 hours. And this is and it say the property one. The other property say that uh, the well n of t count the person who arrive between the time 8 that it's when Walmart opens and to the time t, and this variable count to t to t plus h. But this property say us that n of t is here, the a to t, and the other interval is uh, T to H, and this is we this interval won't occurrence at the same times because for example n of if t is equal of 9 o'clock, n count of 8 to 9, and the other interval count uh, 9 to 9 plus h. If h is equal 1, count 9 to 10, and uh, like the person who arrives in 9 to 10 no depends to the person who arrived 8 to 9. We say that uh, these these events are independent because the intervals and disjuncts. It's mean it one occurrence at the same time. This is a graph of Poisson process. It's any Poisson process because I working with random numbers, and I only ordered from smallest to largest to guarantees the independence of the process now. And for to graph, we use t equal an 8 and an intensity of 1. And this is how look a Poisson process. We can see that uh, is a discrete variable who no depends the second the no depends here, no depends of who arrived here. It's our independence, and this is a Poisson process. Well, we can return to our to our exercise, and the first exercise say find the probability that more than 1 hour will pass without anyone getting to. Well, we define n of 1, which is number of customers that get into in 1 hour, and we need that in this hour uh, anyone getting into. Um and obviously n of 1 has a Poisson distribution with a parameter of lambda that is the intensity for getting to 4 person per hour, uh, multiplied by the time that is 1 hour. Uh, so n of 1 has a Poisson distribution. We can write the probability that in 1 hour anyone getting into, and is equal to e elevated to minus 4, and we solve, and is 0.01883 0.01831. And the second exercise, it's a estimating the probability that exactly 1 person has gotten into before 8:30 a.m. and that a total of 5 customers have gotten into before 10:30 a.m. Well, we we have interval 8 o'clock to 8:30, and 8 o'clock. Well, 8 to 8:30. We have 1 person, and 8 o'clock to 5:30, to 10:30. We have 5 person. Uh, we write the probability of the person who arrives in 8 to 8.5 is equal 1, and the person who arrives 10 and a half is 5. But these events, if we can separate because are independent, and we can write in this form. Um, uh, uh, um, well, I wrote this probability because uh, we have that 8 o'clock in the interval of 8 o'clock and 10:30 got into 5 customers. But if we uh, subtract the one person who got into 8 and 8:30, we have 4 persons. So we have that the probability that the person who get into in a half hour and a person who get into the in the in 2 hours is equal 1 and 4 respective. We uh, we substitute values in this formula, and we we get this expanding exponential and simplifying. We have this, and if we solve the exercise, the result is 0.0155, and that is my project.